In 2022, the Nobel Prize in Physics went to 3 scientists. Not for building something. Not for discovering a new particle. For proving that reality is broken. Here is what they proved. Take 2 particles. Entangle them. Separate them by any distance, a lab, a city, a galaxy. Now measure one. The other one instantly takes the opposite state. Not fast. Not light speed. Instantly. Albert Einstein called this spooky action at a distance. He spent 30 years trying to prove it was impossible. He was wrong. And understanding why he was wrong will change how you see the universe. Let's start with your intuition. Because it's going to lead you exactly to Einstein's mistake. Imagine you take a pair of gloves and ship one to Tokyo without looking at it. The moment you open your London box and see a left glove, you instantly know Tokyo has the right one. Did information travel faster than light? No. The gloves were always that way. Einstein believed quantum particles worked exactly like this. 2 particles interact. Each gets a hidden instruction card, spin up, spin down, decided at the moment of interaction. When you measure one, you learn what the card says. The other card was always the opposite. No mystery. No spookiness. Just ignorance being resolved. This is called the hidden variable theory. It's elegant. It's intuitive. And it is definitively, experimentally, mathematically wrong. The question that tore this idea apart is deceptively simple. Were the outcomes decided before we measured? Or does measurement create reality? To understand why this matters, you need to understand what entanglement actually is. When 2 particles interact in the right way, their quantum states become linked. They are described by a single, joint wave function, one equation for 2 particles that cannot be factored into 2 separate descriptions. In physics, we call this a non-separable state. In plain language, the particles no longer have individual identities. Before you measure either particle, neither one has a definite spin. They exist in superposition. You saw this in the last episode with Schrödinger's cat. But here's where entanglement goes further. When you measure one particle's spin, say, you get up, the wave function of the entire system collapses. And the other particle, no matter where it is in the universe, instantly resolves to down. Not because a signal traveled. Not because the particles were prearranged. Because they were one thing. And you just measured the whole thing at once. Think of it less like 2 gloves and more like 2 pages of the same book. You can't know what's on page 2 while page 1 is unread. The moment you read page 1, page 2 becomes determined, not because information traveled, but because they were always the same story. This is what physicists call an EPR pair, named after Einstein, Podolsky, and Rosen, who published a famous 1935 paper arguing this proved quantum mechanics was incomplete. They thought the non-locality was evidence of a flaw. It turned out to be evidence of how reality actually works. For 29 years after Einstein's paper, this was philosophy. Then John Bell changed everything. In 1964, Bell asked a ruthlessly precise question. If particles have hidden preset states, if Einstein is right, what statistical correlations between measurements would we observe? He did the math. He derived an inequality. Any hidden variable theory, any theory where particles carry secret instruction cards decided before measurement, must satisfy this inequality. The correlations cannot exceed 2. Quantum mechanics predicts a maximum value of 2 times the square root of 2. About 2.83. This is not a philosophical debate anymore. This is a testable prediction. A mathematical bet. Now you run the experiment. In 1982, French physicist Alain Aspect did exactly that. He created entangled photon pairs from a calcium atom. He sent each photon to a separate detector. He varied the angle of the polarizers fast enough that no signal could travel between the detectors before the measurement was made. The result? Bell's inequality was violated. Every single run. Exactly as quantum mechanics predicted. Einstein's hidden variables, the glove model of the universe, was ruled out. Not mathematically weakened. Not questioned. Ruled out by experimental evidence. And then Clauser and Zeilinger spent the next 4 decades closing every remaining loophole until there was no escape. In 2022, the Nobel Committee agreed, non-locality is real. 3 implications that should keep you awake at night. First, non-locality is a feature, not a bug. The measurement events on entangled particles are space-like separated, no signal traveling at light speed or below could connect them. Yet the correlations exist. This means the universe is non-local at its foundation. There is a kind of connection between entangled particles that transcends space. This does not violate special relativity, it reveals something deeper about the structure of reality. Second, and this is crucial, you cannot use entanglement to communicate faster than light. When you measure your particle, you get a random outcome. Up or down. You cannot choose which one. Your partner with the distant particle also gets a random outcome. The outcomes are correlated, but neither of you knows it until you compare notes through a normal channel. Non-locality without signaling. The universe threads an impossibly fine needle. Third, the experiments kept getting better. Zeilinger's group entangled photons and transmitted them 143 kilometers through open air between the Canary Islands, La Palma and Tenerife. They closed the so-called locality loophole, proving that no hidden influence could have coordinated the results at light speed. The correlation survived. The universe really does connect particles across distances with no mediating signal. Here's what makes this more than philosophy. Entanglement is useful. Quantum cryptography uses entanglement to generate unbreakable encryption keys. Any eavesdropper trying to intercept the entangled photons disturbs their quantum state, and the disturbance is detectable. Physics itself becomes the security system. Quantum teleportation has been demonstrated in laboratories, not teleporting matter, but transferring a complete quantum state from one location to another with perfect fidelity, using entanglement plus a classical channel. The particle on the receiving end acquires the exact quantum state of the original. And quantum computers, which we will explore in the next episode, use entangled qubits to hold exponentially many states at once. A classical computer with 4 bits explores one of 16 states at a time. A quantum computer with 4 entangled qubits explores all 16 simultaneously. Scale to 300 qubits, and you have more simultaneous states than there are atoms in the observable universe. But here is the thing that lingers after the physics lesson ends. The universe told us something about itself. Reality at its deepest level is not local. Particles do not have private, independent existences. They share something. A non-local wholeness that no classical metaphor fully captures. Einstein believed God does not play dice. The universe replied with something stranger: the dice are entangled. In the next episode, quantum computing. How entanglement and superposition combine to build machines that could break every encryption standard protecting your bank, your government, your internet, and simultaneously simulate molecules that might cure diseases we cannot touch today. If this video opens something in your thinking, the next one will push it further. Subscribe. We post new physics every week. And if you want to go deeper on entanglement, Bell's original 1964 paper is 6 pages long and written for anyone with calculus. It's linked below. See you next week.